All
Cribl
right.
TV. Thrilled to be here today. It is a lovely day in Atlanta. How's it out in San Diego?
The sun is finally out. The rain is gone.
There you go. Gotta love that. Finally get your good weather back.
Yes, yes. It's and I just came back from Palm Springs and Joshua Tree earlier this week. It was a little cold in Joshua Tree, but with the sun out, it felt nice.
Boy, I bet that was pretty.
It was really pretty.
Yeah,
A lot of
good Joshua
spring
Tree's
blooms. Spring blooms, especially after all these rains. Yeah, it's amazing.
Oh wow, that'd be incredible. That'd be great, some great pictures.
I've got lots of those.
Very cool. So this is Cribl's Ed Bailey and Ahmad Carrig. Ahmad's the architect, the knower of all, the supreme being to talk about how to deploy Cribl to get your best results. So as we keep talking, we're talking about the Cribl Reference Architecture. Today we're going to be talking about scaling for high volumes of agents, but what I like to call too many agents, so many agents, like, oh my God, what do I do now? And so, Ahmad, can you guess, what do you think? Give us, what's your feedback? What's your thinking here?
Yeah, usually for sizing Cribl environments, we care mainly about how much volume of data comes in per day and goes out, right? So the total throughput. But in the case of where you've got tens of thousands of agents, that we also have to take one other thing into account and that is, what is that agent to Cribl worker process ratio? So it's an extra thing we have to account for in the case where customers have tens of thousands of agents that are going to be communicating directly to the Cribl workers.
Yeah, it really is. And this is something you have your own conceptions, but you start talking to customers. Like, yeah, I got 100,000. We got one customer, 800,000 endpoints. I almost fell out of my chair. I was like, how many? And it's just, and those are, and it's just only going to grow. It's going to grow and grow.
Country, 800,000.
Yes. Yeah. It was just like, wow. And those are the things that are very important, how you account for that data, and especially in today's distributed world, because you're not only talking about servers, you're talking about workstations, laptops, IoT devices. I mean, data's coming from everywhere.
Yeah, and the importance of it here with Cribl is, if you think about it, every one of those agents is establishing and also probably consistently opening and closing TCP connections. And a process on a Linux host can only handle so many of those TCP connections coming in. So it's not usually a problem when we're looking at hundreds or thousands of agents, but tens of thousands is when we definitely need to start looking at a little closer.
Yeah, and to go even to more details, that's the thing you don't consider is that connection overhead. That number of connections, regardless of the amount of data, adds its own overhead and its own complexity to your servers. Not to mention file handles, and then the rate of data, the format of data, and those are the things that really just. And then also let's talk about the data governance aspects. I think are very important as well. If you're bringing in data over the internet, so laptops talking over the internet or data coming across from cloud, you have to then start thinking about segmenting your worker groups to handle even more considerations. So it's just there's a lot of things to think about. And so just great to get your feedback and just kind of think about, how do we get started? How do we share these things? And so to make my boss happy, we're going to have a little bit of structure. Let's have a couple of slides. So as we're talking about with our reference architecture, we're going to hammer this home even more. We're going to talk about the starting point, not your end state. How to handle lots of agents, lots of different agents. Another thing to talk about increasingly in a lot of environments is not just beats. It's not just the UF. It could be multiple agents. We're going to talk about guidelines and guardrails for handling agents, and then a few closing thoughts. We're also going to give some best wishes and maybe a little thoughts and prayers, because this is not the easiest thing to solve. So let's get started. Let's get a nice diagram here. But first, we got to pimp our reference architecture. Thank you to the team for writing this up. Oprah wants to give you a reference architecture. Here's a great QR code. Take a nice picture of it. It'll take you right to the link. Very exciting. You got to love it. Now, to the diagrams. So, Mon, why don't you walk us through this?
So this is one of the 4 reference architectures that are in the documentation link that Ed just showed. And in this case here, we are basically, rather than having a shared worker group where you're collecting from this large volume of agents, you're collecting syslog, you're collecting other things, maybe from Microsoft Office 365, things like that. Instead, here you're segregating the workload and you're keeping those high volume agents dedicated to their own worker group. And more so here, in order to reduce latency, we have the option where we're putting these worker groups by location. And so maybe you have one data center where you have thousands of servers, where thousands of virtual machines, tens of thousands of virtual machines that are all going to be talking to Cribl. That can be the location one worker group. And by segregating it out, not having syslog or any of the other stuff on there, you're also now, if you have to do any updates to the Cribl workers, they're not going to be affecting any of the other protocols that are going into Cribl, because those will be going through other Cribl workers. So that's the first thing. And then also you're isolating these worker processes so that they're not going to have a conflict to process something from syslog and something from all of these tens of thousands of agents and potentially cause any conflict. You're basically isolating all of that to really guarantee better success at the end of the day. So important to really think of a dedicated worker group for the high volume agents, and maybe multiple to think of location just to keep the data segregated out.
I think that's well said. I think that isolation, especially by location, is really important. It gives you also the ability to monitor. If you're trying to home run your data off your workstations to another data center, so you have a lot of variables you cannot account for if you're doing that. So I highly recommend having your worker groups inside your data center to give you that segmentation. It also gives you that ability to fail small. So you're not failing for multiple data centers, you're failing for one. And it gives you that ability to monitor, give you that ability to manage, and then also that ability to scale. So I mean, just what really well said.
And one other important thing to also consider with this kind of an architecture where you have multiple worker groups like this is think about your destinations. If you're writing to Elastic, if you're writing to Splunk, if you have one worker group talking to a Splunk indexer cluster, that's TCP connections from every worker process out to those Splunk indexers. For both Elastic, for Splunk, and a few other destinations, you want to think of a setting called the max connection setting. You want to tune that so that you don't overwhelm your destinations now with too many connections that we're architecting for here than ourselves. You don't want to create that, make that a bottleneck for the destination. So just think of the max connection settings as well for those destinations.
Yeah, that's a really good point. I remember putting in Cribl, and we actually created better throughput, and we started overwhelming our indexers. We moved the bottleneck closer to the indexers and caused a problem. So that's definitely something to think about.
Yep.
But like with so many things in Stream, there's ways to handle that. There's ways to manage that. It gives you options. I think that's so important for the admins out there to have options to handle different situations.
Yeah.
So
sorry, go ahead.
No, go ahead. Sorry.
In this diagram, we also are showing how you can have the data sent to a data lake as well as the analytic tool. In this case, it's one data lake, but you know what? That might be different data lakes. Maybe location one is in APAC, and you'll send it to a local data lake over there. Maybe location two is in Azure over here in the US. So maybe you'll write it to a blob storage. But so you can have different data lakes as well with this breakout, if you will, of these different worker groups.
That's a great point, especially for international deployments. You may have different types of requirements, especially around data sovereignty and privacy, that segmentation enables you better to support those requirements. So, for example, if you're picking up endpoint data in the EU, you're going to fall in scope under GDPR. So you're going to have more options with the workstation actually with the worker group located in the EU than you would as if you were trying to say home run that data back to the US. You're home running it somewhere else. And so this is going to give you even more. So always think about when you're managing data, it's not just your data and your speeds and your feeds, but also your governance requirements. So GDPR, privacy regulations, and also if you're handling other types of sensitive data. And this is we're getting a little bit ahead of ourselves, but make sure you have some guidelines and guardrails for if I'm handling PHI, PCI, that you have your worker groups, and then also you put a minimum, regardless of how little data, at least 2 workers in your worker group so that you account for your HA. And I think by giving yourself clear guardrails, that you'll make your deployments a lot smoother.
Yeah, and I always like to go n+1. So whatever number of workers that I size based off of calculators, I always like to go at least 1 extra to account for bursts.
Yeah, and our scaling guides give you, by default, they're going to give you 150% typically of your planned data. But just if you have a business resiliency requirement to sustain more than 150% of your daily average, then you need to think about upscaling that even more.
That's right. Absolutely.
And just from an administration standpoint, the thing that just fell in love with Cribl right away was everything wasn't a one-off. Everything was a group. I could manage sheep and and cattle and not my pets. And so I could, I got a worker group. I can add another server. It takes the exact same code of all the other worker groups. It was just way too easy to manage fleets of workers, and made it really simple. So take advantage of that, and don't get yourself in a situation where you're pointing all your endpoints at one server.
That's right. That's right. And one quick comment about this diagram and all the other diagrams here in this reference architecture section. You can actually download this and edit the contents within here, right? So you can take this and make it yours, make it map to your locations, make it map to your logical areas and so on. Maybe a different data lake. You can take this and edit it and make it yours.
One thing I wanted to point out, and this is another great thing about Cribl Stream, is that it supports many different agents. It's rare to find organizations that just have one log shipping agent. Through M&A, through different business units, through the typical chaos of large enterprise organizations, truly standardizing everything on one agent gets to be really hard. And so Cribl gives you that just fundamental reality of that different business units may do different things. And so if the enterprise standard's one thing, if you just acquired a company that's using Beats, Cribl can handle that too. So it gives you that common layer to handle whatever you have.
And remain agnostic. Right?
Yes.
Remain agnostic.
Very much so. And that's that superpower of choice and control. You're not stuck. If I don't like this, I can move to something else. And it's your choice, it's your control. And that's just mentioned also Cribl Edge. That's the log shipping agent from Cribl. Of course, it works brilliantly with Stream, and it gives you a lot of updates, but no one's forcing you to use it. You can, if you want to use the UF and Beats together, absolutely. Let's also talk about some of the protocols. You have plenty of agents that just use syslog. You have Splunk that could use HEC or use S2S. You have Beats that's going to use its own protocol going into the API. So we support all those native protocols. So you're going to get the best view of these agents. You're not asking the UF to talk TCP. You're not asking Beats to talk HEC. And so you're going to get really nice native support. Do you have any kind of recommendations about, say you had a typical data center, you got a couple thousand endpoints, that's going to have a mixed view of agents. Would you have one worker group per type of agent, or would you be comfortable mixing those together in one worker group?
Yeah, for 2,000, or a few thousand, I would be comfortable keeping them in the same worker group. I think there's no right or wrong answer for this, by the way. I think it's more just what do you as the customer prefer? The segmentation, the separation of the data. But for me, just keeping all of the high volume agents in one worker group generally works.
Yeah, and I agree. And I think one thing to add to that, be consistent. If you're going to pick to say, okay, we got, if it's less than 10,000 endpoints in one worker group, that's what we're going to stick with that globally. Try to avoid one-offs and snowflakes. Just be consistent. And because I think both of those options work, but it's just be consistent and also provision accordingly.
One important thing here to also consider that we haven't really talked about is your load balancers. So for a lot of these agents like Fluent Bit or Fluent D, they're going to be sending to a load balancer that is in front of the Cribl workers. And so it's important to configure those load balancers correctly and have no sticky sessions. So Cribl doesn't like sticky sessions, so that we can have the data distributed across different workers. So yeah, just know that load balancer configuration is also important for some of these protocols, some of these agents. Not all of them, but for a lot of them.
Right. For the ones that support HTTP or HEC delivery, also some of these only do syslog. And so you just understand how the agent works and how it's outputting data and manage it accordingly. Now, luckily, for the most part, the agents support auto load balancing with their native protocols, which you absolutely want to use. You like for the Splunk UF, you don't want to put that through a load balancer using S2S, but because it gives you that nice distribution of data. See, I said distribution, not spread this time. So I'm doing better.
And Cribl Edge is the same way, where also there's a setting there for load balancing, right? So you always need to turn that on.
You're going to get lovely scale this way with the auto load balancing, because you're going to be able to engage all your workers. And typically agent delivery is the benefit is that auto load balancing, you're going to get nice even distribution. You're going to get the ability to fail over if there's a problem. And so that it's great, but also be aware other agents don't do that. And so there's just know your agents and know your options.
Exactly. And so one of the next things here also to talk about is, well, how do you size for this? How do we size for this?
So you want to walk through the scenario?
Yeah. So the earlier we're talking about typically for sizing for Cribl, it's based off of your ingest per day, right? And now when you're taking thousands of agents into account, we have a couple of guidelines that are in this reference architecture documentation page. And basically from our testing, when you have agents that are very low EPS, so they're not generating that many events, say they're only generating 3 EPS, we've shown that one Cribl worker process can handle as many as 5,000 of those agents. So if you have a Cribl worker with 14 worker processes, say it's a 16 CPU system, so that's 14 times 5,000. What is that? That's
that equals a lot.
Yeah, right. So it's like 70,000 or something like that agents there. I think I did that right. That one Cribl worker can handle. But let's be honest, how many of your agents generate 3 events per second? Right? Probably some, but not many. That's where I like to instead use a medium chatty agent volume of 30 EPS more as my baseline.
Right.
And for that, this is where we recommend about 250 agents per CPU, per worker process. So you can see a number went down quite a bit, but we're being conservative with these numbers, right? We're intentionally being conservative with these numbers. And so this is where you take that 250 into account, and that 14 worker processes again, 250 times 14 will give you then 3,500 agents that one worker can handle. And usually, you're going to have 3 workers in a group like that, and so it'll be able to handle a few thousand agents there in a 3-node worker group. For a super chatty, like say a domain controller, where it might generate upwards of 100 EPS, events per second, that's where you want to account for that with like 150 of those agents per Cribl worker process, right? So based again off of those throughputs, the up to 5,000 agents if they're only doing 3 EPS average. If they're doing 30 EPS, 250 is the number to use. If they're doing 100 EPS, 150 is the number to use. And this again is all in that documentation page.
Yeah, and it's really important, I think, to use that. And as we mentioned before, over and over again, this is a starting point to get you 75% of the way to then to take your own unique requirements and add that to it. Because otherwise, you're just going to be messing around to find out. So we want to limit how much you're messing around. And that's for the YouTube censors, to limit how much you have to mess around to get started, because everyone's going to have a certain starting point. And so we're not giving you your end state. We're going to give you, we're going to try to get you as much there as humanly possible.
Yeah, that Ed
Mhm.
hit on a very important point
Right.
here, is that these reference architectures are exactly that, a starting point. Consult with your Cribl team, consult with Cribl PS in order to validate the architecture and just make sure that all the odds and ends are all accounted for.
Right. And it's important to think about this before you get started.
Mhm.
Once you know you're going to be making you're going to get Cribble or you're going to use the free product, have these conversations early on so that we can help you get started and start getting value with as few problems as possible. Because this is typically where we see problems, is where people especially under provision their architecture, then they turn on the data and then everything starts falling over or they have a bad experience. And so our sole goal is to get you started in the best possible place, so you're getting value from Stream and not fighting with Stream.
That's right. That's right.
You feel
And
like
on the documentation page, again, there's a couple of scenarios as
Mhm.
well that show this, sizing for different scenarios. So there's one that's 40 terabytes per day throughput and 40,000 agents. So
I'm
you
gonna go back
first,
to the link again. Got the QR code. Hit up this QR code to get you onto the documentation links that we're talking about. Go ahead.
yeah, no. So there's the one
Mhm.
first scenario there, 40 terabytes a day, 40,000 agents, and 10% of those fall into the very chatty category, while 90% of them fall into the medium chatty category. So we have a formula there to demonstrate, how many worker processes you'd need there. But sizing based off of volume here actually wins. In this case, 205 worker processes are required for the 40 terabytes. And so you would go with the 205 worker processes versus the 171 that came from the formula for the, the
Yep.
connection sizing,
Yeah,
right? So
those are all very important. And one thing, don't forget, your agents all produce a certain amount of internal logs that, especially for low volume agents, the internal logs are more than your actual data. And so you just want to consider that into your sizings as well, because that data is getting delivered. And just one thing I used to do is we actually had a custom route that would route our internal logs to a whole separate worker group to keep them out, so that way we didn't have to account for them, because those are little things you don't think about until it matters.
yep.
So we got a question from William. Could you touch on how you position Cribble in a retailer SIM provider? What's the cost savings and other benefits? So I think we got a minute. You want to kind of pivot and answer William's question?
This is about Cribble for a retail environment where they have
Yeah.
tens of thousands of not just agents, but locations as well.
Yeah,
Where they're,
something about tens of thousands. But let's say we position Cribble with a retail, Cribble in a retailer for a SIM provider. All right. I mean, let's assume it's a retail establishment for a SIM. And so how would we put Cribble? Say you got Lowe's, for example. And so you got every shop or Home Depot. Every Home Depot or Lowe's is essentially a data center that's going to be generating data that needs to go back to the mothership, to the SIM. And so you're talking about lots of locations, lots of data, potentially slow WAN links. So how would you apply our lessons learned to that?
Yeah, so the data can, depending on what agent is used, if it's Cribble Edge, will actually compress the data going outbound. So perhaps in the big stores or maybe if there's a large concentration of stores in one region, you might put a worker group in a data center in one of those regions, or maybe in a cloud provider that's closest to that region. And so you'll create more regional worker groups where there's those large concentrations. And the value of using Cribble here is, one, you can remain agnostic with your SIM vendor choice. You can always route a copy of your data to an object storage, regardless of what your SIM of choice is. And so you'll always have an extra copy of it there for extra analytics, because guess what? You're gonna need to access that data for either audit purposes or some threat hunting use case, that because the data might have expired in the SIM, because you don't want to keep 3 years of data in the SIM. You want to be a little bit more cost effective than that.
Yeah, from an architecture perspective, especially if you have retail locations, I've seen that there's a half rack of servers sitting in the location. And so the idea is that you would have your endpoints in the location with Stream deployed there. And that way, then Stream gives you that ability, just like Ahmad mentioned, to compress and shape that data before it hits your WAN to go to Stream in your data center. And also just that principle of a data lake. Split your data into your data lake, or your hopefully it's your object storage, and only put the data you need into your SIM. So that way you're going to give yourself resiliency and also cost management, because you're not putting everything in your SIM. Most SIMs are a really poor data lake. It's not where you want to do your analytics, not where you want to do your retention.
Yeah, and while we might think, does it make sense to put a worker group in each store, for example? That I think would probably be an overkill, and have too many workers to manage at that point. I think having them more regionalized is probably a better approach, where you have a manageable quantity. They're also centralized, and you also can actually minimize your WAN traffic going out, because if you're with Cribl, part of the value prop is to route data to multiple places.
Right.
Well, the agent would just route data to Cribl worker outside of the network there, right? So they're sending the data out once versus sending it out twice or more times if the worker was at each location.
Right.
So yeah, probably a more regional worker group approach would work.
Yeah, a lot of it's going to depend on your details. I mean, some of these big stores could have several hundred endpoints in them. And so, if you're going to Cribl up into your data center, and then you split your data to your data lake and your SIM up there, can give you a little bit more control. But it just depends on how much data your sources are generating.
That's right.
Just what you're doing in your requirements. But I think the main point is those options. So, William, thank you for letting us know about. Hopefully we answered your question, but we appreciate it. Anyone else has a question? We're here to help.
And if you don't have an agent of choice already, you can always look at Cribl Edge, or maybe you're not happy with agents that are out there. Look at Cribl Edge as that agent to collect the data, and again, it will compress it on the way out, going to Cribl Stream.
Yeah, retailers got a lot of challenges. You think about how many point of sale systems you've seen, and if you look closely how potentially old their data processing systems are, you're potentially going to get things that are not necessarily new in terms of your options for data. And so just there's a lot of challenges there. Think about all the security threats especially against your cash registers, point of sale, payments, all your customer information. So retailers have a major challenge, and especially in this particular macroeconomic environment.
That's right.
Yep. So, you got any closing thoughts for us?
Yeah, just when you're looking at sending tens of thousands of agents directly to Cribl, please always consult here our reference architecture. Take into account the number of agents that you have. It's not going to just be purely on ingest volume. You also have to account again for these number of connections.
Yeah, absolutely. Guidelines and guardrails. Use the reference architecture to get you started, and think about segmentation, just like Mom was saying. Segmentation to give yourself some scale, and also plan for if you're going to fail small. Also, don't forget about your data governance requirements as well. But we really appreciate everyone. If you have questions, so we're on social media. Come to the Cribl community, to cribl.io/community. Sign up for our Slack channel. We also have our lovely sandboxes. If you want to get your hands on the product, give yourself 5 to 10 minute investment. You can see how easy it is to get work done. And so that way you spend less time moving data around and more time getting value from your data. We really appreciate everyone's time. Ahmed, thank you as always for being here, sharing your wisdom, sharing your experience.
Yeah, no, thank you for having me. And have a great weekend, everyone.
Absolutely. Hey, enjoy your weekends. Hey, you got the sun in California.
No rain.
There you go.
All gone.
All right. Take it easy. Have a good day. Bye-bye.